Good afternoon, folks, and welcome to another one of our virtual tours of outer space. My name is Josh. I have the rare privilege of being your pilot today as I take you around our representation of the entire universe. So I'm part of the Morrison Planetarium team at the California Academy of Sciences, and I regret to inform you once again, I have forgotten my vest at work, so I just got the purple shirt today. But when we are in the dome, we love giving our audiences shows that are live and pilot-driven, and it is my privilege to bring that same kind of experience down to our shelter-in-home times, where I get to send a program from my house to yours. So follow Nicole's lead. Let us know where you are tuning in from. We would love to see where we are reaching with these broadcasts. It's always kind of a fun thing for us to check out, especially after the fact. But today, we are going to stretch our minds a little bit using the OpenSpace software, which is Planetarium software you can actually use at home. So normally when folks say, oh my gosh, I saw a Planetarium show, it was super cool, how can I do that at home? The expense is pretty high up there. Licensing Planetarium software can cost a pretty penny, but this is something special and unique. This is free Planetarium software, paid for by you, the American taxpayer. It is a NASA-funded project done in conjunction with a bunch of museums, but chiefly, I would say, the American Museum of Natural History and a bunch of other collaborators. So using this software, we can really stretch our minds and mental legs and really go see some distant spots. My producer, Mary, asked if you knew where we were looking at. Technically, we're looking at the sun. We're just a great distance away. We are just about 20 parsecs, coming up on a little over 60 light years away from our spot in the universe. And as we get farther and farther out to, let's say, about 80 light years, you'll notice we're popping outside this kind of geometric Tron-looking ball. But this is a representation of an area in space, and one that we really like calling the radiosphere. Why the radiosphere? Well, you could imagine that human beings started broadcasting strong radio signals, strong enough to punch out of our atmosphere, about 85 years ago. And over that time, they have spread out into space about 85 light years. And that means that we have reached stars with our light signals that are 85 light years away. That's what this thing is. This giant bubble represents all the spots in the universe our light signals could have reached. Now, this isn't just like broadcasts of I Love Lucy. Technically, that came a bit later. This is also light from atomic bomb tests, the electromagnetic radiation that was released in those moments, flying out into the universe, and every single spot that falls inside this bubble is a place that our signals could have reached. And check this out. See all those blue dots? Those are planets we know exist, planets around other stars. That means that on any one of these spots, there's a potential our signals could have been received by somebody. Now, we don't have evidence that there's aliens out there, but when you look at just how many stars have planets going around them, I think it's a little naive to assume that none of them have life. However, I can say with confidence, we haven't received direct proof that there is life out there. So, Warrior was asking about 55 Cancri E, which is a terrifying planet. I would agree. It's not at all a fun place for me to imagine visiting. We describe it as like a place of hot lava with rock raining from the sky. Is one of these exoplanets. And technically, depending on who you ask, an Earth-like exoplanet. So I would say always be a little skeptical when an astronomer says, oh, it's an Earth-like planet. Don't imagine you could go visit it based on that simple criteria. Astronomers have weird definitions about what makes a planet Earth-like. So if you wanted a habitable, hospitable planet that is just like Earth, we haven't found one yet. We don't think there's a spot where human beings could get dropped off and effort-free survive, no problem, or at least not proof that a planet is like that. We have a couple that are getting close, and as we discover more and more planets, I think people are getting more and more optimistic that eventually one day we will find one that really does fit the bill. But for right now, and even with all these planets we know of, there is only one spot where we can really study the planets up close and personal, and that is, of course, our own solar system, the planets that fall closest to the sun. So I'm taking us back to our solar system, but I want to give us one last parting glance out into the depths of space. Check out this super cool thing right down here. Can you see this blob of stuff right there? Now, that blob almost looks a little organized, like there's dark bars within it, little rectangles. That is the Kepler field of view. So that is where the Kepler Space Telescope stared for about 4 years. And over that time, noted every single time a star got dimmer and then brighter again. And by paying attention to when a star got dimmer and brighter, we were able to notice patterns. Some of these stars got dimmer in a repeatable way. And that is a great proof that there is, in fact, a planet traveling around that star, and one of the most successful planet detecting methods human beings have ever come across, which is a super cool thing. But as we get back to planet Earth, I want to ask if there's another spot in our universe that you think would be a great place to visit. By all means, throw it in the chat. I would love to take some suggestions about someplace else we could spend a few minutes on our virtual tour of outer space. Earth is really cool. I got to touch on it briefly when we did our cosmic conversation last Friday. I love looking at Earth. Whenever you're feeling like you're deprived of vacations, as many of us are these days, take a vacation on your home computer. There's great software like OpenSpace, even Google Earth. You can fly around and see some really amazing, beautiful stuff on our home planet. If you want to get farther out, I think OpenSpace does it a lot better than Google Earth. There's a very finite ceiling. But Google Earth can take you to Mars. That's a really cool thing to do. And there's tons of visualization softwares that allow you to do some really cool exploring. So we have a question coming in. Did we already visit where the recent mission landed on Mars? We have not. That is Jezero Crater. I can take us down to Mars. I keep meaning to transfer over bookmarks for Jezero because we have definitely visited it in several of our programs. However, it is really hard to find without something pointing you the correct direction to go. So I will fault myself and not OpenSpace for being deficient in my Martian geography, which we decided a couple weeks ago should be called areography or areography for the knowledge of positions on Mars. It gets a little tricky whenever you don't have big rivers or continents or stuff to pin down. When you're just going on similar looking dark features, you can use things like Valles Marineris or the Tharsis Plain to navigate. But I will tell you, oh boy, are there a lot of craters. Lisa asked a really cool question. On average, how far apart are things floating in the asteroid belt? So Lisa, when we talk about the asteroid belt, I think a lot of folks immediately call to mind stuff like Star Wars. I love Star Wars. Star Wars is one of my favorite intellectual properties, but they do really bad asteroid belts. What do I mean by that? Well, if we wanted to check this out, I'm going to fly us a good distance away. We were targeted to Mars, remember? So keep track of where Mars is. Out between Mars and the next planet out, we've got a really big gap. And somewhere in that gap is our asteroid belt. So if I turn this on, I believe, so this is kind of a tricky thing. One of these buttons will crash my computer, and I don't remember which one. So these are the Amor asteroids. These are the Apollo asteroids. You can see they're both very spread out, but there's a great population of all of them there. Here's my question, though. When you look at this, you could almost imagine it being a super densely packed region like we talk about in Star Wars. So what's so inaccurate about that? Well, in order to visualize this stuff, we have given those asteroids very long, glowing tails that are much, much bigger than the object itself. Imagine if every car on the highway had a 40-foot-long glow-in-the-dark streamer behind it. On a packed traffic day, you would just see streamers. You wouldn't even see cars. So that's the story here. When we talk about all these objects, we only notice them because of this digital effect we put on them. If it wasn't for that, you wouldn't see them at all. So here's a really cool idea. If you imagine standing on one of these asteroids and looking out into space, you wouldn't know that there are other asteroids there. This would basically be like you alone on a little rock in the universe. I think that is absolutely amazing. So when you think about an asteroid belt, think about kind of a lonely, dark object in a field of other invisible objects, but they're so small and so distant, they would be completely invisible. I think that's really cool. So zooming back from there, let's leave off with one last really cool asteroid group. We talked about these a while ago. There's our Mars-crossing asteroids, and then there's some of our potentially hazardous Earth-crossing asteroids. So the Mars-crossing asteroids could one day bonk into Mars. When you're looking out here, there's a lot of things that could potentially bonk into Earth, and these are all objects we really want to pay attention to. We have a great opportunity to understand the biggest objects in our solar system. However, learning about the smallest objects is something that is really challenging. Imagine trying to find a charcoal briquette at night on a dark field. It's going to be tough because the object doesn't reflect light, it absorbs it, the background is dark. It's going to be a huge challenge. You kind of have to feel around with your fingers, and that's a poor option in space. So if you want to find these objects, we actually don't use visible light. We've got a great trick that is turning on our infrared detectors. And infrared systems can see the warm glow of the asteroid compared to the cooler background of space. So that's proving a very successful way to hunt down asteroids. But we still don't know about the majority of the things that are out there. Based on the percentages we see every time we look, we estimate we've got about 1-ish% of the total objects that are out there. We've found the biggest ones because those are the easiest to spot. But in terms of the little ones that can still cause a lot of damage, we are still dialing in exactly the best way to detect those. Okay, so we're zooming back in. Let's see if there's some other spots. I kind of flew right past Mars, and I feel bad about that. So let's take another swing to Mars because I think it's so cool. We can even take a stop at one of Mars's moons because everybody knows I love moons, especially this moon, which is Phobos. So Phobos one day might be a human gas station on the way to Mars, which I think is just the coolest, most sci-fi thing ever. Imagine pulling into Phobos for a full tank. That just sounds really cool. So in order to see Phobos a little better, I'm going to turn on a color layer and a height layer. There we go. This should give us a little bit more accurate representation of Phobos, because normally we can cheat with a lot of our technological wonders and just draw a round thing and apply the planet's skin to it. But Phobos really isn't round. It's oval in some directions, it's bumpy in others, it's got large craters on the surface that actually change the curvature around it. This is a teeny tiny moon. You really do get a chance to see that from some angles. It looks absolutely bizarre when you compare it to a large moon like our own. So when we're looking at Phobos, and you can say that, you're looking at the dark side, so it's hard to see. One of the coolest things about this moon is its remarkably low density. So when we think about Phobos, it's got much less in common with like a block of granite that is very dense and very solid, a lot more in common with like a lump of pumice, in that it would be airy with lots of vacuoles, empty spaces within it. Some people suggest that it's not actually as puffy as our models would indicate, and that it actually has a lot of water ice in it, and that's where the gas station idea becomes really tantalizing. If there was an ice ball orbiting Mars, that would be a great place for astronauts to stop and fill up their hydrogen tanks in order to continue on through the solar system. I think that sounds really cool. Can you see some of the man-made objects left behind on the surface of our moon using OpenSpace? You actually can, not as three-dimensional objects, but as things on the surface of the moon. However, I think you need a special Apollo scene loaded up for that. I have that loaded on my computer, but I'd have to turn off OpenSpace and turn it back on, and I think that's bad showmanship on my part. But I will say, if you want to download the recent build and go to the Apollo 17 landing site, you can zoom in, and on the ultra high resolution photography, you can see little dark things that were left behind by the Apollo astronauts, some of which are personal refuse bags. Others are geophysics experiments. There's actually the little cars they drove around in, the rovers that are still on the surface of the moon. And it is such kind of cool space archaeology to get to dive in and see the physical evidence of human beings having hung out there. Okay, let's see. I just zoomed away from Mars again. Let's try another object in the solar system, and maybe my attention will hold on to it for long enough. So I talked about how round objects are. Let's go check out Jupiter. When we start talking about how round something is as an indicator of size, generally it's a really good rule of thumb. We have some very erratically shaped asteroids out there because they are such small objects. There's not enough stuff there to squish them around. When we talk about Phobos, the moon of Mars, it's bumpy and lumpy because it's a very small object. Likewise, Jupiter has tons and tons of little tiny objects going around it that are called moons, but are basically just asteroids. When we look at Jupiter itself, it's round. When we're using a computer model, it's got a round shape to it. But if you were to go over your screen with a protractor, or really Jupiter itself, you'd discover it's not perfectly round. It's what we call a spheroid, meaning like a sphere, but not exactly a sphere. What's happening is Jupiter is spinning so fast that its equatorial region, the middle part, is expanding outward. So you could imagine this if you've ever thrown something that's kind of squishy, like maybe a ball of Play-Doh or bread dough, while you were spinning it really fast, the middle part will extend out. It's the secret behind tossing pizza to get a nice flat shape. Jupiter is spinning just fast enough that it's not pizza shaped, but it is a little wider around the equator than it is from pole to pole. So when something is sufficiently big and spinning fast enough, it becomes less round again. I think that's a really cool thing, that teeny tiny things aren't round, really big fast spinning things aren't round. But when you look up teeny tiny things that are fast spinning, that's when you get the weirdest shapes imaginable. There's cool things like Bennu that we think actually have that bulgy area because of some rotation. Okay, so taking a big step backwards away from Jupiter, I'm going to take a moment to look at some constellations, because I think I see one of my personal favorites right behind where we were looking, and there's a star we can see in it that is experiencing the same phenomenon to an incredible degree. So right now, if we were to look out, you can see behind Jupiter a constellation called Leo. And Leo is that reddish shape. You can see kind of a hook. And if you're looking at the sun, I'm going to try some fancy piloting and see if we can get our sun directly lined up with the star Regulus. So Regulus right there underneath the question marky hook part. That is a star that is not that far away. I think it's about 40 light years distant. But that star, pardon me, not supposed to do that, is spinning so fast, it's actually shaped like a pumpkin, which I think is the coolest thing ever. So if you want to look up Regulus, there are some really cool scientific articles trying to figure out exactly what's going on with it, how a fast rotating star might affect its star's life over long term. I wrote a couple papers on it. It was really fun. But Regulus, I will say, is one of my absolute favorite stars because of that. It's just kind of got a weird situation. Okay, let's see. Backing up from our own chunk of the solar system. Happy to take suggestions if anyone has something coming out. Or else I will take a moment to swing by a moon we referenced in our presentation last week that I'm always keen to go check out. I believe this was mentioned as one of Ryan's favorite moons. This is Triton. No, it was Dan's favorite moon. There we go. So zooming out here, we are going to Neptune, god of the sea in Roman mythology, Poseidon in Greek mythology, and we are going to go visit one of its biggest moons. This right here is Triton. So in order to see Triton a little better, I'm going to bring in a color map. There we go. And this lets us see a little bit of detail on the Tritonian surface. Looking around here, you can see one of my favorite Tritonian features. If I told you to look out for the cantaloupe terrain without telling you what to look for, would you know what I was talking about? Probably, right? So this bumpy area all over the surface of Triton looks just like the skin of a cantaloupe. It even has some bruising and interesting features like cantaloupe skin. So these are based on some of the best photos we have of Triton. And lo and behold, when scientists first saw it, it was an absolute head scratcher. There are some color images of Triton too, and that actually gives you a very bizarre version of what we would see with a human eye in orbit around Triton. You would see stuff like purples and greens and grays all across the surface. Some lighter stuff, some darker stuff, but bizarre colors, not like anybody expected. Even some reddish colors, if I recall. So I'm going to see if I can turn off our nighttime shading. There we go. And fly over to the other side so we can really take in how unusual, how wacky this moon looks. So again, these are the best photos we have. Where you see blurry stuff, that's where we just don't have high resolution imagery. Some models can kind of fill in the blanks on best guesses, but this is a purely based on data representation of what we see on Triton. So looking around here, this is a weird looking moon to be sure. There's one last feature I really want to point out before I fly us away. I want you to check out this area right next to the cantaloupe terrain up here, where you can see some interesting contrast between light and dark. almost like the colors are smearing together while remaining relatively separate. So when we got these photos, again, a lot of scientists were scratching their heads. This is something that was new and begging to be studied. Well, turns out we've actually found a pretty good analog, something that is very similar in many ways and helps us really understand Triton better. And that is much farther from the sun. That's Pluto. So we're going to go fly out to Pluto, and on the way, when we found Triton, it was a big moon going in an opposite direction from the rest of the moons. Oh, I forgot to turn off my constellations. Hold on one second. I'm being sloppy out here. So when we zoom in to Pluto, we actually get to see sort of an echo of Triton. Now, Pluto's a little pinker. The colors are different. This representation shows it as a gray, a contrast between light and dark. You'll see many similar features. Instantly, you can see that kind of mottled colored surface. In the low-res photos, looks exactly like Triton. But in the high-res photos, you can see what's causing that are very steep mountains, very strange valleys, a huge amount of impact sites, and an active surface. Nowhere is it more active than what we call the plain region, which is this super smooth area right here. And this is where we see that kind of nitrogen goop collecting on the surface. Goop, again, being the technical term. So when we talk about this goop, it's basically the atmosphere of Pluto, but it gets so cold that it condenses onto the surface. So we see nitrogen, which is often seen as the gas envelope around Pluto, its atmosphere, collapsing, condensing, and adhering to the surface, making this nitrogen-y glacier. Pluto is an amazing active world, and the fact that we got kind of a sneak preview about what was going on by checking out Triton is just so cool. When we had one of our experts in the Plutonian part of the solar system on, Alan Stern, he was talking about there's potential models that suggest that once upon a time there were 2,000 Pluto-like objects in our solar system. But as the solar system evolved, many of them were absorbed or knocked out of the solar system or gravitationally slingshotted away or absorbed by big things like Jupiter or the sun, to the point where we probably have a handful of Pluto-sized objects remaining today, one of which is, of course, Pluto. I would put Charon in that category as well, and Triton too. There's a couple Pluto-y kind of things a little farther out, but they are not a common kind of object, let's say, compared to stuff like asteroids. Part of that's because they're larger, part of that's because they're hard to find. So there might be more Plutos out there that we're still waiting to discover. Okay, let's see. There's no more suggestions. I'm going to start taking us back towards Earth. And on the way, there's many cool things to see. And ask about the accuracy of the colors. You've seen Jupiter as gorgeous blues lately, but I don't think that's the color right. It depends on the filter you have on your camera when you take the photo to a large extent, Lisa. So many filters might exaggerate the bluish colors in order to give us more understanding of what's causing them. That doesn't mean it's more or less accurate. It's presenting different information. Like if I took a picture of my backyard in black and white, you could say, oh, well, that's less accurate. It's not what we see, but it is actually what the camera sees in a lot of ways. It just gets a count of whether or not something is bright or dark under a specific filter. So Juno, I would say, is paying a lot of attention to Jupiter's clouds. And if you've seen an up-close picture of Jupiter lately, it is from Juno. So that is likely something that a scientist is studying specifically, where the bluish color helps them better understand whatever phenomenon they're looking at. Okay. I will say, though, that a lot of these OpenSpace images are dialed in for either representational black and white, which is just data, or close to what a human eyeball would see. Like Earth, this isn't a black and white surface. We are seeing a color photo of Earth, but it's close to what a human eyeball, the average human eyeball, I should say, would see from orbit around Earth inside a spacesuit, because if you just had an eyeball by itself floating around Earth, it probably wouldn't be seeing very interesting stuff. You can see something very interesting here, though. I love it when this happens. You can see perfectly where one day's data bumps into the next day's data. And it looks like someone has a, if you ever take one of those pano photos and somebody moves in it, the clouds keep moving so fast that we always have a mismatched seam opposite the part of Earth that we call the Greenwich Meridian. So that's going to be over here, and I bet we will find England right there, because that's where we take our 0 time for our dates from the Greenwich Meridian. And if you look opposite the Greenwich Meridian, that's where you always have this funny looking seam. You can also see a cool representation of time in this SWOMI data. It's taken from a satellite orbiting our planet. This reflection you see repeated over and over again, kind of a band of bright light right there, right there. And that's what happens when we are seeing a photograph that was taken at noon. Basically, light from the sun is bouncing off of Earth and shining back up to our spacecraft. So sunlight gives us that bright band, and you can keep track of where photos were taken at noon as it flies around and around planet Earth. So this is a really cool thing. Before, when we had a question about what you can see of human-made stuff out in the universe, I was thinking that was just in general, not specifically on the moon. And I do know I have one human-made thing currently loaded up. That is our very own International Space Station, the ISS. The ISS used to be how we would start this show inside the planetarium because it is such a cool way to establish a human scale as opposed to the rest of the universe, which is completely not at a human scale. So I think today I'm going to take us out by flying around this ISS and asking all of you to imagine how amazing and how special it would be to be on board the ISS, maybe looking out that little cupola down onto planet Earth and seeing all of this wonderful, beautiful planet fanned out before you. So with that thought, I will thank you all for tuning in. If you have questions or comments, please leave them in the chat. We will do our best to circle back to them. On behalf of myself and the Morrison staff and the good folks at AMNH and OpenSpace, thank you all for tuning in. We are going to drop, right after this program is done, a link in the comments for you to fill out a survey. And with that survey, you can be entered in a drawing to try and get a NASA meatball sticker mailed to you at your house. So if that kind of thing sounds super cool to you, by all means, fill out that survey. We'll be dropping it in there shortly, and let us know. Again, on behalf of myself and Morrison Planetarium, thank you all, and have a wonderful rest of your day. Cheers.